In this video, we're going to find polynomials that have a given degree with a given zeros, and this time we're going to use complex zeros. So recall that if you have a complex zero, a plus bi, that a minus bi must also be a zero. Okay, so they always come in pairs. Okay, so let's look at the first problem. It says we have degree 3. That means that our highest power is going to be x to the third once we write this thing all out. Okay, and we have two zeros that are given. We have -4 and we have x plus 2i. Okay, so we can go ahead and write our third here. We also know that, did I say x plus 2i? I meant 3 plus 2i. Okay, we can write 3 minus 2i as another zero. Okay, so our three zeros are written here. And if we wrote it in factored form, we'll call it f of x. This would be x minus -4. And then x minus 3 plus 2i, and then x minus 3 minus 2i. Okay, so this one, of course, would be x plus 4. Okay, and on this, I'm going to go ahead and multiply this out. Okay, so I'm going to, like I did in the previous video, I'm going to use that as 4 terms to multiply. So I'm going to keep the 3 plus 2i together. Okay, so that will give me x times x is x squared. X times this term gives me negative x times 3 minus 2i. Okay, and then this x times this term gives me negative x, because of this negative, and 3 plus 2i. Okay, and then finally we get this term times this term. The negatives cancel out. Okay, so you will get plus 3 plus 2i, 3 minus 2i. Okay, so that's this whole thing right here is this being multiplied out, and this x plus 4 is from here. Okay, so let's multiply out some more. Let's distribute some more. So there's the x plus 4. We haven't dealt with it yet. We have an x squared, negative 3x, positive 2ix. It's this one. Negative 3x, and then negative 2ix. And then this is a difference of squares, a plus b, a minus b. Okay, so remember a plus b, a minus b, if you're multiplying, you get a squared minus b squared. So the first term minus the second term squared. Okay, so this will be plus 3 squared minus 2i squared. Okay, let's take care of this first. If you square the 2, it becomes 4. If you square the I, it becomes I squared, which is -1. Okay, so this becomes -4 times -1, which is 4. Okay, so that last term, instead of negative times 2i squared, we're going to write a 4. Okay, and we can cancel out these two terms. So we get x plus 4. Let's see, we get x squared. Let's see, minus 6x. And then this is 9 plus 4, which is 13. Okay, so that takes care of that. And now we can go ahead and finish multiplying it out, assuming that they want it written this way in the problem. So we can go ahead and multiply this out. I like using the box, so let's use the box over here. Keeps things organized nicely. Okay, the 3 terms go on top, x squared minus 6x plus 13, and on the side we get an x plus 4. Okay, let's fill in the boxes by multiplying. So we get x cubed, negative 6x squared, 13x, 4x squared, negative 24x, and let's see, that would be 52. Okay, and then we can combine like terms on these two diagonals. Okay, so this is going to give us x cubed, comes from this box. Combine these two, we get negative 2x squared. Combine these two, and we get negative 11x, and then plus 52. Okay, so that's the polynomial f of x. All right, let's look at this one. So it says we have degree 4. This was a mistake. It had 3, but it's actually 4. And the reason for that I know that it's 4 instead of 3 is because it says this one has multiplicity 2, so that takes up 2 of them. And then we have negative I as one of the zeros. If negative I, you could write as 0 minus I. If that's a 0, then 0 plus I is also a 0. Okay, so we know that I, we don't have to write the 0 plus I, but that's the complex conjugate theorem. So if negative I is a 0, then positive I must be as well. Then multiplicity means this term will get squared. So we have f of x is equal to x minus a negative 4 and x minus a negative 4, which is the same thing squared, and these will turn into plus, and then x minus negative I and x minus positive I. Okay, so let's go ahead and write this as x plus 4 times x plus 4, and then this one would be x plus I, x minus I. Okay, so I'm going to multiply these two separately and these two separately and get two different answers. Okay, so this one, multiply it through, you get x squared. The two middle terms would be 4x and another 4x, so it becomes 8x. And then 4 times 4 is 16. There's that term. Okay, and then this one, let's see, this is a difference of squares right here. So the difference of squares, a plus b, a minus b. So it'll be x squared minus I squared. Okay, so that gives us, let's see, x squared plus 8x plus 16. And then we have x squared. Remember, I squared is negative 1, so negative and negative make positive, so plus 1. All right, and now I can use the box. We'll use it over here. Okay, so this gives me x squared, 8x, 16. You can put the pluses there if you want. And then x squared plus 1. All right, let's fill in the box. This is x to the 4, 8x to the third, 16x squared, x squared, 8x, and 16. Okay, it looks like there's only two like terms. It's the 16x squared and the x squared, which becomes 17x squared. So this polynomial is x to the 4th plus 8x cubed plus 17x squared plus 8x plus 16. Okay. Let's do one more. Let's do this one here. Okay, so this is degree 4. So this is a 0 of 3, negative 4, and 1 plus I, which means that 1 minus I is also a 0, using the complex conjugate theorem. So f of x is equal to x minus 3, that's the first one, x minus a negative 4, that's the second one, and then x minus 1 plus I, and x minus 1 minus I. Okay, so that will be x minus 3, x plus 4, and then we'll keep those written in the same way. Okay, so again, we can do two separate multiplications. We can do this one separately from this one. Okay, and on this one I'm going to keep these parentheses together. So when I do this, I'm just going to be using 4 terms. Okay, so the first one becomes x squared minus 3x plus 4x. And we multiply the middle term, so that's just plus x. And then minus 12. Okay, so it takes care of that one. The next one, we get x squared, so those two, x times this term, so negative x times 1 minus I. And then this times this is negative x times 1 plus I. And then the last one would be plus, because it's two negatives, 1 plus I, 1 minus I. Okay, so let's multiply some stuff out here. So that'll be x squared minus x plus ix minus x minus ix, and then this is a difference of squares. So the first term squared minus the second term squared, so plus 1 squared minus I squared. Okay, cancel, cancel. This becomes a negative 1, and then the negative in front makes it a positive 1. Okay, so this whole thing becomes 1. Okay, so I get x squared plus x minus 12 times x squared minus 2x, and then plus 2. Alright, to do this one, using the box, we will need a 3 by 3 box. Okay, so let's do that. So here we go. Okay, so on top I'll put x squared plus x minus 12, and on the side I'll put x squared minus 2x plus 2. Okay, and you could do either side. You could flip these if you wanted. Alright, so let's multiply that through. That becomes x to the 4th, x to the 3rd, negative 12x squared, negative 2x cubed, negative 2x squared, positive 24x, 2x squared, 2x, and negative 24. Okay, so notice the diagonals will be where you have your like terms, so that's nice. Okay, so we get x to the 4th, no like terms. These two combine to give negative x cubed. Let's see, these two cancel out completely and leaves the negative 12x squared. And these two add together to give 26x, and then minus 24. So that is your f of x polynomial with, reminder, 3, 4, and these two complex conjugates.